Alright, so, like I said, solutions to operations on solutions, and then we're going to talk about changing forms. All we got to do today. Should be pretty easy, pretty quick. Alright? Alright, first things first, find the sum of the solutions to the following equations. Well, what's the key word in there? Sum. What, Quentin, what does that mean? Add what all up? What does it say? So we're going to add what?
Solutions.
Add the solutions. Pretty simple. So we're going to solve it just like we did yesterday and the day before. And then we're just going to add the solutions. Just one of those things we got to do. Hey. Shh. So, first one here. I have a term squared. I do not have x squared and x. I want to get that squared term all by itself, so I'm going to add 25. X minus 3 squared equals 25. Right? Once I get that squared term by itself, I'm going to take the square root of both sides. And x minus 3 equals, what's the square root of 25? 5 and negative 5. So x minus 3 equals negative 5. Then we can solve both of those.
Hey, Chief.
Hey,
Have a go on.
thanks. Gucci.
Chief. What?
Regional Leadership Conference FBLA winner.
Oh, yeah.
First place.
I never made out of the ultimate computing, but
Hey, you don't gotta tell people that. Just like we went to trivia the other night. We took top 5.
Wait, what did he say?
There were 5 teams.
Oh.
Took 5th. Man, you don't gotta tell people how many people were competing.
So when they ask you, then you.
Well, just like in high school, I put my first car in the demolition derby. Took 3rd place.
Was that on?
Out of 4. We beat somebody.
you're not the worst.
You're right. It was a lot of fun though. I was the 3rd, second loser. Numbers are hard. Alright. What?
So if you're not first, you're last.
True.
What class did you go?
What?
Class did you go?
Not our class. So they're really getting a lot of content right now.
8th hour? 8th hour?
7th, I think.
8th hour!
Shh.
Take
That's
you
right.
back.
Hey. Alright. Add 3 to both sides. Back to the math. Back to the math. X equals 8. Add 3. X equals negative 2. Wait, hold on. I shouldn't be putting a box around those, should I?
Because you have to find the sum, so that's not the answer.
I need to find the sum, so those are not my answers. Oh, I need smaller. I'm erasing the boxes. Hey, so I need to find the sum, so I need to add my 2 answers together. 8 plus negative 2 equals 6. That's the sum of my solutions. 6. That's my answer. Okay, guys, and make sure it's not x equals 6, right? My solution isn't x equals 6. It's just 6. I added my 2 solutions together. My solutions were x equals 8 and x equals negative 2. X does not equal 6. That's just the sum of the solutions. Okay? Alright, second one. Second one, I look at it, it's got x squared and x in it. That means I need to factor it to solve. But first I need to get a side equal to 0. Already done. Sweet. So, let's factor. Right? Our favorite F word. Oh, second favorite F word. Behind FOIL. What multiplies to negative 27? Adds to 6.
93. Negative 3, actually.
9 and negative 3. So x plus 9 times x minus 3 equal to 0. Set each side equal to 0. X plus 9 equals 0. X minus 3 equals 0. Minus 9 minus 9. X equals negative 9. Oh, don't put a box on it. Add 3. X equals 3. So x equals negative 9. X equals 3. Kelly, what do I need to do?
Add up the sum, or add up to get the sum.
Add up to get the sum. Negative 9 plus 3. Negative 6. Sweet, you just learned how to do operations on solutions. Whoa, crazy. All right, any questions?
I go back to 8th hour.
No.
Me and Billy. We'll trade. JJ and Luke. That'd be a good trade.
Eighth I would be losing there.
We get to hang out with Colin.
Well, that's if Colin ever shows up. He's always sick. All right, let's talk about changing forms. This way is the easiest. Going from vertex form to standard form is easy. All right? Going from vertex to standard is easy. All you're going to do is we're going to take this piece that is squared and we're going to FOIL it. This said that 2 minutes ago. We're going to FOIL it. So what we're going to do, y equals, if you try and distribute that squared, I will hunt you down. You cannot distribute your exponent. That is not allowed. It turns into x minus 2 times x minus 2. You need to FOIL. Y equals x squared minus 2x plus 4 plus 5. Right? We're just FOILing that squared term. We get y equals x squared minus 4x plus 9. Once you combine your like terms, it is then already in standard form. Wow, how nice was that? So, FOIL out what you got here that's squared. Combine your like terms, and you're in standard form. That's all it is. Right? The second one. Y equals x plus 1 times x plus 1 minus 6. So I get y equals x squared plus 1x plus 1x plus 1 minus 6. Right? FOIL it out. Don't lose this plus 5 and that minus 6. Don't lose those. And then combine your like terms. Y equals x squared plus 2x minus 5. And you're in standard form. Pretty easy, right? This is the easy one. Try the third one. I'll do it on the board as you do it on your paper. Then we'll compare answers to see who's smarter. Hopefully we're all just as smart as each other.
There can only be one. That's it. I finished first.
Go back to high school.
That wouldn't mean that. It would just mean you're smarter than high school. Hopefully I got it right. Where do you get that? Right on the board. Sweet. Sweet. You all got that? Alright. Any questions? Any questions? Hey.
No.
Got it. Throw it back. What can you not do, Mr. Reed?
Nothing.
I can do everything.
Yeah, nothing I can't do. Anything you can do, I can do better.
Okay, I beat you in pig.
I don't think that's true.
I even have a little E up there for you, but there's nothing there, you see?
Alright, hey. Alright, guys, let's talk about the other way. The other way is a little bit more difficult, but honestly, once you get the hang of it, it's really not hard at all. Alright? So, to change from standard to vertex form, we will use completing the square. Have you guys ever done that before?
No.
Completing the square? Okay. So, hey, guys, up here. So, perfect squares, we're looking to get something that factors into two identical pieces. That's how we're going to complete the square. Our goal is to get it to factor to two identical pieces. Alright? So, being a perfect square means the expression can be broken down into pieces and arranged nicely into a square. Like I said, identical pieces, like x squared plus 6x plus 9 factors to x plus 3, x plus 3, and then that changes to x plus 3 squared. What that's going to do for us is it's going to get us into that x minus h squared, that part of that vertex form that we need. So that's where we're going to complete the square. Now, how to create a perfect square. Do you guys see a pattern here? At all? What do you notice?
The number at the end, the 9, 16, and 25 is a perfect square.
They're perfect squares. Wow, yeah. Okay, what do you notice? Do you notice any pattern with how they get to be those perfect squares, Q?
They're multiples of each other.
They're not. 25 is not a multiple 10.
Wait, no, I meant, never mind.
What are you talking about?
Hold up,
You good?
hold up.
And you have an idea. You do have to use the middle number.
Is that the
That's a
thing?
good start. You have to use the middle number. Yeah.
Well, I looked at it
Hold
and
on.
like it was 4 times 2 was like the power, and then 4 to the second power is 16. So it's almost like you're multiplying and then squaring it.
It's almost like what we're
The
gonna
thing
do,
we're gonna do is
okay?
3, 5, 7,
Shh, listen. What we're gonna do is we're gonna take this middle number, 6, and divide it by 2, which will give us 3. And then we're gonna square it. That'll give us 9. So you're gonna take your middle number, and you're gonna divide it by 2. 8 divided by 2 is 4. And if I square it, I get 16. Whoa. 10 divided by 2 is 5. If I square it, I get 25. It works. Crazy. So, how many examples do you guys have? I thought you only had 2. 2. I don't know where that example's coming from. Alright, so, what do you got, Q?
First one, 64.
First one, 64. I take 16. Divide it by 2, I get 8. Square it, I get 64. So to complete that square, I would put 64. Now, the one down here, negative 20. Negative 20 divided by 2 equals negative 10. Negative 10 squared equals 100. So it'll be plus 100. It will always be a positive number that you're putting on there to complete the square. Alright? Now, we're going to see why we divide it by 2 in a second. But for right now, you just got to trust me. Can you do that? Yeah?
Yep.
Anna? Yeah? Okay. Alright, so let's talk about changing it. What is it? We just talk about this. Okay, so when we're completing the square, we won't always have a blank because we're starting in standard form. What we're going to do is we're going to divide that b term by 2. We just said that. Divide your middle term by 2. Square the number. What's going to happen is you add that on and it becomes a perfect square. But this fourth one down here, that's not a star. That was pretty bad. That fourth one is really bad. Alright, so that fourth one is super important. Whatever you add to make it a perfect square has to be subtracted as well. Alright, and we'll see that when we do an example. But that is super important. If you just add something to it, you're changing the equation. What we add, we must also subtract so we don't change the equation at all. We'll change the appearance of the equation, but it won't actually change the equation. Does that make sense? So whatever you add on to complete your square, you also have to subtract. Okay? We'll see that in the first problem. So, y equals x squared plus 8x plus 33. The first thing I'm going to tell you to do. First thing I'm going to tell you to do is I'm going to tell you y equals, and in parentheses, I want you to put x squared plus 8x, leave a space, close it, and then put plus 33. So x squared plus 8x, leave a space, plus 33, because what I want to do is I want to complete this square right here. Right? So plus blank. I need to figure out what to put in there. Okay? So I'm going to take 8, divide it by 2. I get 4. 4 squared gives me 16. Right? So I get y equals x squared plus 8x. And I'm going to add 16 on the inside, plus 33. And we said whatever we add, we also have to subtract. So if I add 16 on the inside, I need to subtract 16 on the outside. Okay? So we're completing the square for x squared plus 8x. But you can't lose that plus 33. Now, what happens is I can factor what I just completed the square for. What does this factor to?
X plus 4.
X plus 4, x plus 4. Plus 17. Right? 33 minus 16 should give me 17. The last step to changing to vertex form is making it say y equals x plus 4 squared plus 17. Now it's in vertex form. So we complete the square so that when we factor it, we get x plus something squared. Alright? Now, do you notice x plus 4? When I divide that by 2, I got 4 as well. What's happening is I'm dividing it by 2 because I need something that adds to that, or excuse me, I need something that multiplies that 16, and I know it's going to split into the same thing. So I need to split 8 into the same number. So if I divide by 2, I know I get 2 parts that are exactly the same. Okay? So the idea is break it up, complete the square, factor it, and then write your final answer. Okay? Should we try another one? Okay. Example, x squared minus 16x plus 74. Same thing, f of x equals x squared minus 16x, leave a space, plus 74. Right? Take your middle number. Take your middle number, negative 16. Divide it by 2. I get negative 8. Negative 8 squared will give me 64. So what I'm going to do, x squared minus 16x plus 64 on the inside. Whatever I add, I must also subtract. So add 64 on the inside, subtract it on the outside. Should factor to x minus 8, x minus 8. Notice, when I divide it by 2, I got negative 8. It's the same thing here. X minus 8 plus 10. So the last thing I need to do is write my function as an answer, as a solution, x minus 8 squared plus 10 in vertex form. So going from standard form to vertex form, we're completing the square. A little bit more difficult. Okay? Are there any questions about that? We good? Alright, I think we have 2 more problems to do, right? Where we're going to convert them and then we're going to graph. Whoa. Oh. You guys can try those. Oh, crazy. So I'll give you guys a few minutes to try those. If you have questions, I'll go around. If you have questions, please ask. Yeah. It's a mess right now. If you don't want to Valentine's Day tree, you don't need to take one. Valentine's Day. What's so funny?
What's the candy?
They were.
Snickers. Oh, ratted out. You can't. It's not allowed. No fun in this room. See, look at that. You can't go like a minute without smiling. I'm just that. I just can't put through that much. I'm so happy every time they're around me. You're welcome. I'm done. How's it going, guys? So, complete the square and then graph it. You're welcome. Make sure your garbage gets in the trash, please. William?
Dark chocolate?
No, it's a lava cake. What?
What's a lava cake?
It's like chocolate with runny chocolate.
First one again.
Alright.
Don't break it.
You want me?
Get up in that field. Get up in that field.
Guys, I'll put the answer to the first one up in a second, so make sure you're working on it.
So, it's like an old fashioned donut, but it's just like on the side of the That's why it's hard to tell. But apparently
Oh,
it's
this
like.
is M lava cake.
This is lava cake?
Lava cake. Don't burn your mouth on it, man.
Is it
Lava's usually pretty hot.
Mr. Ray, happy Valentine's Day. Can I have the ring pop?
No,
No, like so cool.
you got Hershey stuff.
What do I get if I get the ring pop? What do I have to do?
What do you do to get the ring pot? Go to the store and buy one.
This ring pop right here, that's what I want.
That's what you want, why is it mine?
What flavor is it?
Hey, have you done the 2 problems?
Yep.
Really? You graphed them?
I didn't grab them.
Oh, make sure you graph them. Yeah.
How do you distinguish positive?
Guys, hey. So remember, we're looking at A. If A is positive, it's gonna smile, it's gonna open up. If A is negative, it's gonna open down. I think both of these should open. Both of these should open up. So first one. You should be done with the first one by now. Check your answer on the board. Give you a couple more minutes to do number 2.
You just super quick one.
So we're looking at this, it says y equals a times x minus h squared plus k. So that's our vertex form, right? So a is always the number rounded here. A is going to equal what here? H equals minus h is going to be minus 3. So h is going to be 3.
Oh, just because it's 8 is not like.
Yeah, just 8, right? If I put negative 3 here, it'd be plus 3. Because minus negative 3 would be plus 3. So a would be 2. So my vertex is always going to be at h comma k. Vertex is at 3 comma 2. 3, 1, 2. And then you know the shortcut here. A equals 1. We're going to go 1 right, 1 up. 1 right.
I don't think you realize how rich Logan's daughter
That's
is.
just not their shortcut. So always
You
use
realize how rich Logan's.
if a equals.
They bought her a house.
If a doesn't equal 1, say it equals 1.
Yeah, but, you know.
We're going to take and multiply these 2 numbers.
The house is $700 million.
So instead of going 1 right, 1 up, I go 1 right.
That's a fortune in itself.
And 1 right. Well,
If you don't, you sell the house,
Okay.
you're $700
The other
million.
two
you
was
also have an axis of symmetry
making a
here.
point.
It always goes to the vertex. And that line is x equals
What's
3.
your Yeah, what's your
Like here
GPA?
you'd go 1 right, 1 up, 1 right, 1
Yeah,
up.
there's no 100.
And then mirror those points.
3.8.
So how did you know how to do
Yeah,
this?
yeah.
Sorry.
This is always a shortcut we use. We went through how we learned how we got that
Yeah, why don't you look it up?
yesterday. So we go 1 right, 1 up, 1 right, 1, 2. Good job. And I just mirror those arrows. Okay. Does that make sense?
Yeah.
Sort of?
Like for example.
Yeah?
Like.
Okay.
Yeah,
All right, number 2 on the board.
why would you take that? Dude, it's not.
What is going on? Number 2 on the board. Check it out. Number 2. How do we do?
Got it right.
Good. So.
Got it right. Got it right. Got it right. Put the ring pop is really.
Yeah.